Hi, welcome to 9.4 Independent Practice. We're talking about surface area here. And our first question is Carla's wrapping a present in the box shown. How much wrapping paper does she need? Not including overlap. This is the surface area. I think that one way to do this is to count how many surfaces there are. There are 6 surfaces here. So I will count what? One. Surface number 1. I'll call it the front right here. So the front, what is that? That's 10 times 4. So number 1 will be 10 times 4, which is 40. There's 2 of these though. There's the front and the back. So number 2 will be the same 40. Number 3. Number 3, I'll call the right side over here, and that's 3 times 4, which is 12. But there's 2 of these, the left side and the right side. So the left side's also 12. That's over here, right there. So they're both 12. And I'm going to erase this. Then let's go with number 5. I didn't do the bottom here down here. The bottom is 10 times 3, which is 30. And the top is going to be the same. They have the same area, so that's also 30. Okay, well, the surface area is the area of all those surfaces added together. So when I add these together, I have what that's going to be 4, and then 4 and 4 is 8, 9, 10. 10 plus 6 is 16. 164. 164, and its area is square units. Because that's how many squares fit on the surface of this. If you imagine this is the surface, how many squares are on that surface? 164 squares, where each side is an inch long. Okay. Okay. Next. Dimitri wants to cover the top and sides of the box shown. I'm going to bring this in a little bit. And erase this because I don't need this anymore. So, how many tiles does he need? Okay. So he wants to cover all of this with glass tiles that are 5 millimeters square. Okay. So let's get the surface area first. And there's 6 surfaces here. So, number 1. Surface number 1, I'll say is the front here, and that's 9 times 15. 9 times 15. 9 times 15 is 135. Okay. Now, there's that, and the other side too is 135. So on the back, you can't see it, but on the back there is 135 too. Surfaces 3 and 4. I'm going to erase this here. Let's go with this front part here, and that front part's going to be 20 by 10. Oh, I'm sorry, 20 by 9, because that's 9 right there. So 20 times 9, that's 180. But not only is the front like that, but the back that you can't see is like that too. So that's also 180. Okay, erase that. And we're missing the top and the bottom. So the bottom or the top right here is going to be 15 by 20. So that's going to be 15 times 20, which is 300. But the top like that and the bottom that you can't see is like that too. Yes, but we don't need the bottom, right? She's putting glass tiles on to see. If we go back here, she's covering the top and the sides. She's covering the top and the sides. She's not covering the bottom. So we only need 5 surfaces. And so that total should be, let's see, I got 135 plus another 135 plus 180 plus another 180 plus 300. That's 930. So this area that we need to cover is 930. Okay. Square centimeters. Okay, now we have these tiles, and each side is 5 millimeters, because they say right here 5 millimeters. So that means the area is 25 square millimeters, and we're going to use that. But there's a wee bit problem here, and this is tough. Look at this. This is square centimeters, and this is square millimeters. For us to figure out how many of these fit into here, they need to be the same measurement. So let's make this square centimeters. Now, there are, this is a little tricky to explain, but 1 square centimeter is equal to 100 square millimeters. Okay, so we're going to use this. If we have 930 square centimeters, then 930 times 100 would be 930 with 2 more zeros. Yeah, uh, square millimeters. Okay, now the question is, how many of these fit into here? And that's division. So we take 930, what, 93,000, that's what it is, divided by 25, and 93, yeah, 93,000, yes, divided by 25 is 3,720. 3,720. So it'd be, how many tiles? 3,720 tiles. And that is, yeah, tiles needed. Oof. Boy, that was tricky. That one little conversion right there is real tricky. Okay. Shara is building a cabinet. Okay. Let me erase some stuff here. And let's see. Oh, I shook the whole thing. Just giving myself some space here. And so she's building a cabinet. She's making wooden braces for the corners of the cabinet. Find the surface area of each brace. Okay, how many surfaces are there? There's the front right here. What's that? Oh boy, I'm going to zoom in on this one. So the area, let's see. I think that what I should do is find the area of this one spot by saying, okay, what's the area of this? The area of this is 1. This is 1 by 3. The area of that is 3, because 1 times 3 is 3. And then this is 1, and this is 2. So 1 times 2 is 2. So the area of this is 3 plus 2, which is 5. So the area of that is equal to 5. But there's 2 of these, right? There's the front one, and then there's the back one back here. So there's I'll do 2 of these. So there's the 2 sides. Okay, so that's 5 and 5. So far we have 10. Now let's figure out what the area of this is here. What is this? This is 3, and this is 2. I know that's 2 because the whole thing's 3, and this is 1. So 1 plus 2 is 3. So the area of that right there is 3 times 2, which is 6. So the area of that front area is equal to 6. And you know what? That's going to be the same as this area right here. So the area of boom, 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 boom equals 6. Let's go with the area. Let me erase some stuff here so we don't have to deal with a lot of stuff. But I'm now looking at this area here. This is 1 by 3. And so this, that 1 by 3 is equal, the area of that is 1 times 3, which is 3. And then finally, the top, well, not finally, actually, there's more. The area at the top here is 1 times 3 also, so I'll call it this is 3. Oh boy, we have the backside too. Let's see that backside. The backside is going to be, let's see, it's going to be this times this, right? So that's 3 times 3, which is 9. So I'll just call it the back is 9, and the bottom, that's also going to be 9. The bottom's going to be this one by this one. 3 times 3 is 9 also. And so we got to add these up. What is 5 plus 5 plus, okay, 6 plus 6 plus 6 plus 3 plus 3 plus 9 plus 9. That's what? This is 10 and 12 is 22. 22 plus 6 is 28. And 28 plus 18 is, oh my God, I can't even think straight. 28 plus 18, I didn't calculate, 46. And so that's what it is. It's 40, oops, it's 46 square inches. Ooh, that was pretty good. Number 7. Whoa, doghouse. So the doghouse has shown has a floor but no windows. Find the total surface area of the doghouse, including the door. Okay. So, okay, well, I guess I'll just go with all the different surfaces here. The first one, maybe I'll do that surface right there. That's what, 2.5 times 4. Let me bring this over here, a little smaller. And so I got, I guess, one surface. Oops, oh boy, that's not good. I'll do that right there. So one surface is 2.5 times 4. That's 10. And oh, there's another one too. On the other side, that's going to be also 10. Okay, number 3. I'm going to erase stuff here. Maybe I'm not. There we go. How about the front right here? So the area of that triangle is the base times height. So 3 times 2. 3 times 2, but divided by 2. That's 6 divided by 2, which is 3. And there's a front and there is a back also. So that is 3 as well. 5. Let's start going to the bottom. And on the bottom, we have, what, 3 times 2. So 3 times 2, which is 6. And there's the backside too. The backside is going to be the same. So that's equal to 6. And then a 7th side. Let's see, a 7th side. What would that be? That is 4 times 2. 4 times 2, which is 8. But there's also the other side, and that's also 8. So that's 8 sides. I think I need the bottom as well. So it says has a floor. So that's telling me to find the area of that floor. And the floor is going to be just 3 times 4. Now I got to add them all up. I think I could do this. What, 10 and 10 is 20. This is 26. 26 and 12 is what, 38. And 38 plus 16. 38 plus 16 is 54. And then adding that final 12 plus 54. So the sum of all these numbers should be, let's see, that total is 66. So it should be 66 square feet. Okay, wow, that was a lot right there. Okay, let's move on to the next one, which is over here. Number 8. Describe 2 ways to find the surface area of the ramp. Okay, well, let's go with one way. I'll call it 1. Uh, uh, calculate the surface area of 2 triangular prisms and 1 rectangular prism. So what I'm saying is you take the surface area of this triangular prism and the other triangular prism and then add to that the surface area of the rectangular prism. Okay, so that's 1. And then 2, calculate the surface area of a trapezoidal prism. So you have essentially what I'm talking about is take the surface, or so instead of that, you could take the area of this trapezoid and then double that, the surface area. Yeah, so double that and then take that and treat it as that perimeter of the base times the height of the prism plus 2 times the base area. This is a formula where your perimeter is that trapezoid base. Anyway, now let's take the surface area of the ramp. Right, that's number 9. And I'm going to zoom in a bit and take the surface area of this. So I'm going to erase this part here. And I'm going to count, let's see, how many surfaces do I have here? I have 1, 2, 3, 4, 5, 6. Under is 6. So I believe there's 6 of them. Okay, the surface area of number 1. I'll call this number 1. What is that? 20 times 24? Yeah, 20 times 24. I believe that's 480. Okay, number 2. What is that? 16 times 24. 16 times 24. I have a calculator available. I should have had that before. So anyway, 16 times 24 is 384. 384. Number 3 is this other side here, which is the same as number 1. So 3 and 1 are the same. That's going to be 480. Okay, how about the bottom? And that's the bottom. So under there would be number 4. And to get the bottom, it would be this length times this length, which is 16 plus 16 plus 16. That's 48 times 24. 48 times 24. And 48 times 24 is 1,152. Number 5. Okay, number 5 I'll call the front trapezoid there. And that is a length, you have to add the 2 bases. So one base is 16. And the bottom base right here is 48. So 16 plus 48 divided by 2. And then you have to multiply by the height of the prism. And that height is given as 12. So times 12. I'll add 16 and 48. 16 plus 48 is 64 over 2 times 12. 64 divided by 2 is 32 times 12 is 384. And we have two of these because the front is the same as the back. So number 6 is going to also be 384. Now the surface area is going to be the sum of all of these areas. So it's that plus that plus that plus that plus that plus that. And I'm going to add those up. So 384 plus 384 plus 1,152 plus 384. Another 384. That's interesting. 384. Oh, plus 480 plus 480 is 3,200. Oops. 3,264. And all of that is in inches, so it's square inches. Okay, so I'm going to take that and place that in the answer. 3,264. 3,264 square inches. Great. And let's see the next. Okay, what's the surface area of the stand? Okay. Well, let's see. I'm going to take a look at all the surfaces here. I'm going to try to move this over as much as I can. And let's take a look at surface by surface. What's the surface area of that? That's 1 times 3. So 1 is 1 times 3, which is 3. Number 2. Let's see. This is 1 times 3. So that's also 3. The front and the back are going to be the same. So that's going to be 3 again. And the surface area of this side is the same as the other side, so that's going to be 3. How about the top? The top right here, this is 1 times 1, which is 1. Okay, I got all that stuff. I'm going to erase I got this whole top part here taken care of. Oh, well, I don't know. Maybe I'll do this. I've taken the surface area of all of that so far. Now I'm going to take the surface area of this. What would that be? That is 3 times 1, right? 3 times 1. So number 6 is 3 times 1, which is, again, 3. I think that this would be the same here, 3 times 1 as well. So that's number 7 is equal to 3. Number 8, let's go down here. That is 1 times 2, which is 2. Number 9, well, this is also going to be 1 times 2 as well, so that's 2. And number 10, let's go with the front here. That is 7 times 2, which is 14. And 11, I should have actually made this, done this in green. So this is 10. And 11, oh, the 11 is going to be the front and the back are going to be the same, so that's 14 as well. And then finally, number 12, the one that's underneath right there, 7 times 1 is 7. And we have to add up all of these together. Let's see. I have 3 plus 3 is 6. Well, 3 times 4 is 12. 13. 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 23. 23 plus 7 is 30. So that part's 30. So it's going to be 30 plus the two 14s. And that's 8. 58, I believe. Yes. And so our answer is 58 square feet. Super. Moving on to Number 11, Marco and Elaine want to paint the entire stand silver. A can of paint covers 25 square feet and costs $6.79. They set aside $15 for paint. Is that enough? And you got to explain. Well, how much is it going to cost first off? Let's see. So they want to cover that entire stand. And so the stand that we're talking about is the one from the previous problem. So we need to cover 58 square feet. Well, we're going to need 3 cans, right? Because 25 times 3 is 75. 25 times 2 is 50, but that's not going to cover it. So we're going to have to find out how much 3 cans are going to cost. And so I would take $6.79 times 3. Okay, so that's 7, 2, 21, 22, 23, 18, 19, 20. Whoops. Sorry about that. 20. So it looks like we'll need $20.37. So they set aside $15. Is that enough? Nope. No. They will need $20. That was an awful dollar sign there. I gotta redo that. So they will need $20.37 to cover the stand. To cover the stand. Okay, there you go. And the next question, number 12. Henry wants to cover the box shown with paper without any overlap. How many square centimeters will be covered with paper? Okay. Well, I think I would go with how many surfaces are there? There's 6. So the front, I'll go with the front here. That's 24 times 10. 24 times 10. And then, what? That's 240. But the front is the same as the back, so there's going to be another 240. And so that's surface 1, surface 2. How about I erase this? I'm going to try to get a little fancy here and go with blue. And surface 3 on the right. That's 27 times 10. 27 times 10. That's 270. And there's another one on the left-hand side. So number 4, that's going to be 270 as well. And then we have, oh, I got to erase that there. And then we have, let's see, I'll go green. We need the top. The top. That's surface number 5. And that's 24 times 27. What? 24 times 27. I don't have my calculator on me, so this is 2, 14, 15, 16, and this is 8 and 4. 8, 4, 548. And the top is the same as the bottom, so number 6 is going to be 548. And I got to do some adding now. Let's do that in yellow. So I'll add everything. Well, that's going to be 16. What am I adding up here? I have 447744. So it's 7 times 2 is 14. And 4 times 1, 2, 3, 4 is 16. Plus 1 is 17. So 17 plus 14. So I got to do on the side 17 plus 14 is but that's 11. That's 31. So 1 and a 3, and then we have 5, 6, 7, 8, 9, 10, 11. 11 plus 10 is 21. So this should be 2116. And all this would be great if I didn't make a mistake all the way over here. Whoopsie. This should have been, I should have carried the 1 on that. So let's go green on this. There's a 1 right there. So this would have been 648. Oh boy. Does it ever end? 648, which would make this 2316. And that would be our surface area, 2316. So I'm going to move this over here. And this is 2316 square centimeters. So both the length and width of the box, let's bring this over a little bit. Suppose the length and width of the box in exercise 12 double. Does the surface area double? Okay, well, let's look at this. I'm going to have to draw, I'm going to erase all this stuff here. So all this is going away. I need some room here. We have the 2316, but I need to compare that to doubling the length and the width. Okay, well, I have this. So what we're looking at is if we double the length, that is 48, and if we double the width, what, that's 54, I believe. Yeah. Okay, so I need to take a new surface area of this. So it's going to be 10 times 54, which is 540, and there's 2 of those. And then there is 10 times 48, which is 480, and there's 2 of those. And then there's 48 times 54. 48 times 54. 8 times 4 is 32. That's 16, 17, 18, 19. And that's 0, 40, 20, that's 24. So 2, 9, 5, 2. That's 2,592, and there's 2 of those. And we need to add all that up. Okay, this is going to be interesting. 25. Let me erase this a little bit here. And I want to move this over because I want to line stuff up so it's a little bit easier to do. So 2592, 2592. Okay, so this one's going to be 4. And what have I got? 9 and 9 is 18. 8 and 8 is 16. So 18 and 16 is 8 and 6 is 14. That's 34 plus another 8 is 42. Okay, now I have to do, what am I looking at here? 5, 10, 15, 20. 20 plus 3 fours, which is 12. 20 plus 12 is 32. So this is a 2 again and a 3. And that's 7. So the question then is, will the surface area double? Well, our original surface area was 2316, and then the new surface area was what? 7224? I hope it was 7224. So from 2316 to, oh boy, 7224. 7224. No, that's almost 4 times the size. That's at least 3 times the size. So, no. No, it is more than 3 times the size. Okay, let's move on. Let's see. Enya. Enya is building a storage cupboard in the shape of a rectangular prism. The rectangular prism has a square base with side lengths of 2.5 feet, a height of 3.5 feet. Compare the amount of paint she would use to paint all but the bottom surface of the prism to the amount she would use to paint the entire prism. Let's bring this down here, and first I'll draw a rectangular prism. I mean that would be a good place to start. So a rectangle and a rectangular prism comes like that. Side lengths. Oh, oh, it has a square base. So this is 2.5, and this is 2.5, and the height is 3.5. Okay. Compare the amount of paint she would use to paint all but the bottom to the of the prism to the amount she would use for the entire prism. Okay, so let's go. I think that probably what we would do is we would compare. Let's go surface 1, surface 2, surface 3, surface 4, and surface 5, and then and 6, right? Compared to just 5 surfaces, 1, 2, 3, 4, 5, and it's not going to be 6 because we'll leave out the bottom. So I'll do the bottom. I guess I'll do the bottom. No, I'll do the side. I'll do this side. I'll do the right side here. 2.5 times 3.5. So 2.5 times 3.5 is, well, let's see. That is 8.75, I believe. 8.75. And that is this spot right here, and there's 2 of those, so I'm going to do another 8.75, and let's write equal. So number 3, let's see, number 3, well, we have the front, right? The front is 2.5 times 3.5, so that's again another 8.75 for the front and an 8.75 for the back, right? So I have the left side, the right side, the front, and the back. Now I need the top. That would be 2.5 times 2.5. So that's 2.5 times 2.5, and I believe that's 6.25. And there's the top, and the bottom is the same thing too, 6.25. And when I add all of these up, I'm going to get a total sum of 47.5. 47.5. Yeah, I believe that's it. Okay, so that's all 6. But now I need to compare that to, so they're saying right here over the side, compare it to just all the first 5 without the bottom. So that was the area of the bottom. The 2.5 times 2.5 is 6.25. So let's take out the bottom. So that means I'm going to compare that to, I'll do it in green, I guess. So we have the 8.75 and the other 8.75 and the other 8.75. All the sides are still there, but the bottom 6.25 and no top. So there's 5 sides to this. And when I add that up, I get 41.25. 41.25. And so now we need to compare the two. I'll use division to compare them. I'll take the 41.25 and I'll divide it by the 47.5, and what I get is equal to, let's see, I get 0.87, which is 87%. So so 87%. I got all that stuff here. So compare the amount. So what I'll say is uh, the surface area. without the bottom is 87% of the total surface area. Eh. Um, okay. All right. Next. The oatmeal block shown is shaped like a cylinder. Use a net to find the surface area. You know what I'm going to do? I'm going to show you the formula. Uh, this is not usually shown until 8th grade, but I'm going to show you the formula for this because I think this is just going to be way easier. Okay, so I'm going to erase all this stuff here to give myself some room. And I'm going to share with you this formula for the surface area of a cylinder. So, the surface area, SA, for surface area of a cylinder. That is commonly known. It's easy to look it up, but it's 2 times pi times the radius squared plus 2 times pi times the radius times the height of the cylinder. So I'll just fill it out. Let's see. I'll move this over a little bit. So 2 times pi, we'll call 3.14, times the radius squared, and the radius is given as, let me move this down, is given as 2, right? It's right there. The radius is 2 right there. So I will write times 2, but that 2 has to be squared, following the formula, and then plus 2 times pi again, 3.14, times the radius, which is 2, times the height of the cylinder, which is given as 9. That's right here, 9 right there. So, times 9. So you multiply all this stuff out, and let's see. I believe that what you get is, this is, what, 25.12, I think? So this is 25.12 on the left side, and then plus, and on the right, you should get 113.04. 113.04 when you multiply all that stuff. And then when you add those two items together, you would get 138.16. 138.16, which is about rounded to the nearest whole number, which means we have to stop right there and we have to look at that number to the right. So it should just be 138. Okay, I'll just call it 138. It's about 138. Oh, you know what? I'm sorry. I totally forgot something. I totally forgot something. I didn't do one little thing. Okay, so yeah. So what I'm going to do is I'm going to add these up. It's if I round what this is 113.6 138.16 and round, and I have to round. Okay, here they're saying right here, round to the nearest tenth right there. So I have to round this number to the nearest tenth, which is about 138.2. Okay, now I have to multiply this by 1500 because that's the surface area for one of these oatmeal boxes, but we need 1500. So it's going to be 138.2 times 1500, which is, let me move, let's see, I did that. That's 207,300. So it's 200, oops. It's 207,300. And finally, what you need to know is this. You need to know that what we're doing is we're going to turn this into, well, this is in square inches, I believe. Yes, so this is square inches, but they want it in square feet. And you need to know that, well, if you have 1 foot, if you have 1 foot and this is 1 foot, then together that's 1 square foot. Square foot, okay? But each foot is 12 inches. let me move this over because I got to show you something here. Each foot is 12 inches. So that's 12 inches. And now 12 times 12, if I'm going to say how many square inches this is, it's 140. 12 times 12 is 144 square inches. So what this means is 1 square foot is equal to 144 square inches. So we have these square inches here. I need to take 207,300 and I need to divide it by 144 to find out how many square inches I have. And I did that. That is 1,439.5. And now they say here, they want you to round to the nearest whole number right here, round to the nearest whole number. So when I do that, that would be about what? The nearest whole number means I'm looking at that number. That's 5 or more, so that bumps it up, and that's 9, so that bumps that up. So altogether, it's 1,440 square feet. So I guess we'll write it as feet squared like that. So it's 1,440 square feet. Okay. Now for this one, I decided just to write this out, but I'm going to explain it here. So a prism is made of centimeter cubes. How can you find the surface area of the prism in figure 1 without using a net or formula? How does the surface area change in figures 2, 3, and 4? Okay, so centimeter cubes. So each of these are 1 centimeter long, each side of this. So that means that the area of the front is 9 square centimeters. Okay. Now, if and it says here, what I said is the surface area stays the same when the corner is removed. So when this corner is removed, it's the same surface area because the number of faces showing is still the same. See, this is showing 1, 2, 3 faces right here, and this is showing 1, 2, 3. So this is showing 3, and it's still showing 3. Now, the volume is different, but the surface area is still the same. Now, when we take out these other corners here, if you take out one corner, same surface area. You take out any corner or all the corners, it's the same surface area. So the figures 1, 2, and 3 have the same surface area. Different volume, but it's the same surface area. And now this one has more surface area because we have removed one of these sides here, and we had a surface area of 1, 2 right there. And we still have 1, 2, but we have the left and right side here, 3 and 4. So figure 4 has a larger surface area because 2 more faces are showing, and that's the left and right side of those 2. Right in here. Let me zoom in more here. So again, that's see, this one was removed, so that shows 1, 2, 1, 2, but 3 and 4, the left and right sides, that's added surface area right there. And there you go. That's what you got to know for this, and I hope it's been helpful.